Hey there! Ready to dive into the world of AI? You've got questions, and today we're using your source material to swim through them all. We're going for that crystal clear understanding of AI, not just a surface skim.
It's about getting to the core of what AI is, its journey so far, and what it means for us moving forward.
Exactly. And speaking of core, this source kicks off in a fascinating way by asking, what even is intelligence? We often think IQ tests or being a whiz at math, but this takes it a step further, right?
It broadens the definition beautifully. Rather than one single type of intelligence, the source breaks it down to five key aspects: cognitive, emotional, creative, practical, and social.
Okay, let's unpack that. So someone might be amazing at music, that's creative intelligence shining through. But someone else might be incredible at understanding and connecting with people, that's social intelligence. And we each have our own unique blend.
Exactly. And this blend is what we're essentially trying to replicate and extend with artificial intelligence.
It's like we're trying to give machines their own version of those five intelligences. Now, this source makes a point of saying AI is like giving machines a brain, and I get that, but how does that actually work?
Think of it this way. Our brains have billions of neurons, all interconnected, sending signals back and forth. Many AI systems, particularly those using what's called machine learning, rely on algorithms inspired by this very structure, something called neural networks.
Neural networks. It's like giving machines their own little thinking caps with digital neurons firing away.
Okay, that makes sense. But AI hasn't always been neural networks, has it? Our source mentions AI has been around longer than we might think.
Much longer. It's easy to think of AI as a recent invention, but the seeds were sown way back in the 1950s. Wow, really? Like
Yeah.
back when robots were all chrome and pointy fins on cars were the height of cool.
Exactly.
Yeah.
This is a time when the very idea of artificial intelligence was taking shape. Take Alan Turing, for example. He's considered one of the founding fathers of AI.
What did he do?
Well, Turing, a brilliant mathematician, developed a test to determine if a machine could exhibit intelligent behavior indistinguishable from that of a human. It's called the Turing test, and it's still debated even today.
A test for thinking machines. Now, that is seriously cool. But it wasn't all smooth sailing from there, right? I mean, AI today is light years ahead of where it started.
You're right. Those early days were marked by both excitement and setbacks. There was this almost romantic notion of creating machines that could mimic human thought in its entirety.
Yeah, I can see how that would be captivating.
It was. But early AI programs, while groundbreaking, had their limitations. Think of them as specialized tools, each designed for a specific task.
So not quite the all-knowing, all-powerful AI we sometimes see in movies.
Not quite. One of those early programs was ELIZA, created in the 1960s.
What did Eliza do?
ELIZA was essentially a chatbot. You could have a text-based conversation with it, and amazingly, it could sometimes feel like you were interacting with another person.
Imagine that, having a heart-to-heart with a computer in the 60s. That's mind-blowing. But as our source explains, those early programs were like the Model T compared to today's Tesla. They paved the way, but worked on a totally different engine.
A great analogy. ELIZA and his contemporaries relied heavily on pre-programmed rules. Think of it like giving the program a detailed script for every possible conversation turn.
So kind of limited, right? Like if you veered off the script, Eliza would be lost.
Exactly. But then came the real game changer. A shift from rule-based AI to something entirely new, machine learning.
Machine learning. Like the AI is going to school, hidden the books.
In a way, yes. Instead of being explicitly programmed for every scenario, machine learning algorithms learn from data.
Okay, so instead of a script, we're giving the AI a library card and saying, go learn.
Precisely. The more data these algorithms are fed, the better they get at recognizing patterns, making predictions, and improving their performance.
That's where big data comes in, right? All those massive data sets we hear about fueling AI's learning.
Exactly. And this data-driven approach is what led to some truly remarkable breakthroughs. One of the most iconic examples is IBM's Deep Blue beating chess grandmaster Garry Kasparov in 1997.
I remember that. It was huge news. Man versus machine, and the machine won. But how did Deep Blue go from rookie to chess champ? Was it just crunching numbers faster than Kasparov?
It was more than just speed. Deep Blue, unlike earlier chess programs, used machine learning to analyze millions of past chess games, learning successful strategies, and adapting its gameplay based on its opponent's moves.
So it was learning from experience just like a human player would.
Exactly. And this learning wasn't just limited to chess moves. It marked a pivotal shift in AI, demonstrating the power of machines learning from data to outperform even the most skilled humans in complex tasks.
Okay, so we've gone from rule-following robots to AI that can learn, adapt, and even outmaneuver a chess grandmaster. What's next?
Well, our source delves into something called deep neural networks, a more recent and even more sophisticated approach to machine learning.
Deep neural networks. Those sound intense. Are we talking about AI that needs therapy?
Not quite. Remember those neural networks we talked about earlier, the ones inspired by the structure of our brains? Well, deep neural networks take that inspiration to a whole new level.
Okay, walk me through this.
Imagine a neural network with not just one layer of interconnected neurons, but many layers stacked on top of each other. That's what makes them deep.
So more layers, more learning power.
Exactly. This layered structure allows deep neural networks to process vast amounts of information, recognizing extremely complex patterns that would be impossible for traditional algorithms to detect.
Okay, I'm starting to see the deep part now, but how does this actually play out in the real world?
Think about image recognition. Deep neural networks can now identify objects and faces in photos and videos with accuracy that rivals and often surpasses human vision.
Wow, that's incredible.
It is, and it goes beyond images. Deep neural networks are also powering those voice assistants we use every day, like Siri and Alexa.
So when I ask Siri for restaurant recommendations, it's a deep neural network figuring out what I'd like.
Precisely. They're also behind those eerily accurate recommendations you get on streaming services or online shopping sites.
So basically, these deep neural networks are becoming scarily good at predicting what we want sometimes, even before we know it ourselves.
You could say that. But there's another fascinating aspect of deep neural networks, particularly when it comes to language. This is where those large language models, or LLMs, come in.
LLMs, they sound like something out of a science fiction novel. What are they all about?
Think of LLMs as the ultimate wordsmiths of the AI world. They're a specific type of deep neural network that's been trained on a massive scale, often using billions, even trillions of words and lines of code.
So they've basically devoured every book, article, and tweet ever written.
Pretty much.
Mm.
This extensive training allows LLMs to generate incredibly human-like text, translate languages with remarkable accuracy, and even write different kinds of creative content like poems, code, scripts, musical pieces, email, letters, etc.
Wow, that's amazing. But it also makes me wonder, how do these complex AI systems actually make decisions? I mean, they're generating text writing code, but is there a thought process happening behind the scenes? It's like, are they just mimicking patterns from the data, or is there some kind of understanding happening in there? This source kind of touches on that, right?
It's one of the biggest questions in AI today. As these systems get more sophisticated, understanding their decision-making process becomes crucial. The source actually uses a term for this, the black box problem.
Black box. Sounds ominous.
It's not about being scary, but rather about the inherent complexity of these systems. Imagine a deep neural network trained to evaluate loan applications.
Okay, so it's looking at financial history, credit scores, that sort of thing.
Exactly. And based on its training data, it might get incredibly good at predicting who's likely to repay and who isn't. But here's the thing. Even the engineers who designed the system might not be able to pinpoint exactly why the AI approved one applicant and rejected another.
So it's making decisions, but the why is hidden inside that black box.
Precisely. It's making decisions based on patterns. It's learned from the data. But those patterns and the weighting it gives to different factors might be too complex for even us humans to fully grasp.
That's a bit unsettling, isn't it? I mean, if we're going to rely on AI for things like loan approvals, shouldn't we understand how those decisions are being made?
Absolutely. And that's why this black box problem is such a hot topic in AI research right now. It's not just about building AI that works, but building AI that we can trust, understand, and whose decisions we can explain, especially when those decisions have real-world consequences.
So it's like we need to make sure the AI is playing by the rules, even if we didn't explicitly program those rules ourselves.
Exactly. It's a fascinating challenge. It really speaks to the importance of not just technical expertise, but also ethical considerations in AI development.
Right. It's not enough to just build amazing technology. We have to be mindful of how it's used and the potential impacts, both good and bad.
Precisely. And that's something we all need to be aware of, not just the engineers and researchers. AI is no longer a futuristic fantasy. It's here. It's evolving rapidly, and it's shaping our world in profound ways.
It's like we're all part of this grand experiment, whether we realize it or not.
And that's why conversations like this are so crucial. The more we understand about AI, the better equipped we'll be to navigate its possibilities and challenges.
Absolutely. Well, we've covered a lot of ground today. We've gone from the very definition of intelligence to the inner workings of deep neural networks and even peeked inside the black box.
Hmm.
What are some key things you hope our listener takes away from this deep dive?
I hope they come away with a sense of wonder and excitement about AI's potential. This technology is already transforming industries, accelerating scientific discovery, and even changing the way we create art.
It's mind-blowing when you think about it.
It truly is.
Yeah.
But I also hope our listener comes away with a healthy dose of curiosity and perhaps a few more questions than they started with.
Because asking the right questions is how we shape the future of AI responsibly and ethically.
Exactly. Keep learning, keep exploring, and keep those questions coming.
And on that note, it's time to wrap up this deep dive into AI. We hope you've enjoyed the journey. Until next time, stay curious.